So, recording now. I'm going to pass over to Darren Swift. Darren is one of our sales engineers and is responsible for all aspects of technical overview for the north of the UK. So without further ado, passing over to Darren now, and please do ask questions as you're going along. Don't wait for the episode at the end. Take care.
Okay, good morning. Thank you. As Dave said, today we're just going to do a technical overview of Zerto, and then we're actually going to dive into the software as well. This is being recorded, but please do feel free to ask any questions as we go through, and I'm more than happy to answer them for you. Should you not want to ask me questions during the presentation, please reach out to me on either one of these. It's just darren@zerto.com, and I'll get back to you straight away. So Zerto is designed to assist companies when IT goes wrong, and whether this is planned or unplanned downtime, either planned via migrations, power outages, application upgrades, or unplanned through natural disasters or unforeseen circumstances, the same result is achieved, which is downtime. And when we have downtime, the business making money. Someone's got quite a lot of background noise. Would you mind just muting, please? Okay. What I'd just like to point out here is the difference between backup and disaster recovery. So by no way and means am I saying here that we need to get rid of backup. Backup still has a place within the data centers today. But when you're considering a disaster recovery strategy, you need to have a look at what the business actually needs and what your recovery times are. So we need to start looking at the service levels that you're providing back to the business, the acceptable amount of downtime. Can you afford a performance impacting technology whereby your users are affected by your backup or DR strategies? Are we automating this, or is it just full of knowledge in people's heads? What's our retention, and what does the business expect our service levels to be? So I'm not going to lecture you on backup. We all know backup. It has been around for a very long time. And traditionally what you will do is you will take a backup every 24 hours of your data. Now backup is great for long-term retention. As you know, in some compliance, in some sectors within the UK and Europe at the moment, you're required to keep emails for over 7 years. You do not want to keep that on expensive disks. You will farm that off to tape. So this is where backup is still very, very relevant in the industry today. But the problem is, if backup is your sole disaster recovery and backup strategy, then if you was to have a failure in the middle here, you're going to lose 12 hours going back to your previous point. That's 12 hours worth of data. And if you're an online company, 12 hours worth of data is a huge amount of money. So what do we use on top of backups? Well, we use snapshots. And snapshots are typically taken every 4 hours within an environment. And snapshots are designed to stagger the differences between, or the gaps between, these two backups. But again, this is performance improving. These are not automated, and they require quite a lot of manual intervention to get them up and running. With Zerto, we use something called continuous data protection. And continuous data protection means that we are taking checkpoints continuously over this period. So we are taking a checkpoint every few seconds, and we're not impacting your performance. We're giving you very aggressive service levels and minimal downtime. So that is the difference between the three technologies. And if you can take anything away from today, I'd like you to keep in mind this continuous data protection and what Zerto is giving us. So I'd like to start out with this use case. It's a case local to David Bray and myself, and it's Liverpool Heart and Chest Hospital. So they replaced their manual EPR systems with an automated system, and what they noticed is the criticality of this went up. So the application became critical to the patient end user experience. They was using traditional storage-based technologies for replication, so they was tied into vendors. They was replicating at a LUN level, which means that you are failing over all of the VMs that reside on that LUN, whether you like it or not. Their disaster recovery testing was impactful, so they had to have teams and people to get this up and running, and they needed to prove back to the business that, hey, this EPR system, we can test it, we can deliver an aggressive SLA, we can do non-impacting, and we can simplify the solution. So they went with Zerto based on a few reasons. We're storage agnostic, and we can go from anything to anything, which I'll discuss in the next slide. And we can do automation of all the manual tasks which are normally associated with a manual disaster recovery failover. And this is why Zerto has been so successful in the marketplace, is because we are offering enterprise-class business continuity and disaster recovery solutions for both data centers and the cloud. And as Liverpool Heart and Chest Hospital found out, it doesn't matter whether you're protecting 15 VMs or 5,000 VMs, you still have the same problem. Traditional replication technologies have been replicating at the storage level. They do not understand the virtual world. They were not designed for the virtual world. So what you would normally have to do was to marry two technologies together, such as VMware SRM and also a replication technology of some description. And then there would be a certain amount of migrations, moving the virtual machines around on different LUNs to ensure that you're failing over your LUNs in the correct order. And then there's the added complexity of managing two vendors, two sets of costs, two sets of maintenance, and two support lines. So in large scalable environments, this becomes a real issue because you're managing two separate platforms. So what have we done at Zerto? So what we've done is we've taken replication and we've taken all the automation and orchestration that something like VMware SRM would give you, and we have placed it in the hypervisor. So this gives you some very unique advantages. Let's face it, the workhorse of the data center now is the virtualization layer. Most companies are north of 70% virtualized, if not higher. So it makes sense to have your replication at the virtualization layer and use a product which thoroughly understands the needs of a virtual environment. So Zerto is software only. We do not provide you hardware. We are storage agnostic, which is a big play for some of our customers, such as Liverpool Heart and Chest. Traditionally, when you buy a replication technology from a storage vendor, let's pick 3PAR. You would have to buy two 3PAR boxes and buy the replication licenses between them. With Zerto, we allow you to go from any. We don't care about storage vendors. We don't care about protocols, and we can go from anything to anything. So you can reuse or buy more cost-effective storage for your environment. We are, as of next week, on the 16th, our beta is out for our hypervisor agnostic. So traditionally, we have worked with VMware, hence all the awards down here. And we've been very integrated into VMware over the last 4 years. But as we see Microsoft Hyper-V becoming more and more popular in the marketplace, we have rolled out cross-hypervisor replication. So you might be thinking, what is the use case of that? Well, let's say that a new office is opening or your business is looking at Hyper-V due to the cost benefits. Because if you've bought Microsoft data center licenses, then you will already have Microsoft Hyper-V. So some customers are starting to use this. But then you've got a change in shift and culture. Do you want to train everyone on a Hyper-V and VMware? So what do you need to do? So if you've got small offices, even other sites that you're setting up, you might go Hyper-V, but you may want to replicate them back into VMware. Zerto can do this. We can go from Hyper-V to VMware, from VMware to Hyper-V, Hyper-V to Hyper-V, or VMware to VMware. And we are taking care of all of that machine translation between the two hypervisors. We can even now go from VMware or Hyper-V into Amazon Web Services as well, which again brings massive cost benefits for a DR strategy for a small company who doesn't have the CapEx available to fund a secondary data center. And Zerto is enterprise in class. Now I will show you features as we go through, and I will keep coming back to this enterprise in class. Okay, so what are we doing from the high level? So over here, I've got a primary and a secondary data center, and we are replicating and protecting your virtual machines and application at the VM level. We are storage agnostic, as I said before, so there's no vendor lock-in, and we are an asynchronous technology. So asynchronous is on purpose. With an asynchronous technology, you do not add latency to the writes from your VMs over in the primary data center. And it also means that you can stretch your data centers further apart to take them out of disaster zones. Whereas with synchronous technologies, you are bound by latency and distance between those two sites. We only replicate the changes over from one data center to the next, and we also add compression going over these two sites. This gives us a recovery point objective of seconds, and you will see this through the demo, and you'll see my active recovery points. So first and foremost, why are we enterprise in class with replication? So the first thing that we do with a Zerto instance is we add your virtual machines or your servers which make up an application into a virtual protection group. So if I had a CRM application, I might have a web front end, load balancers, app servers, and DB servers. I would group them all together in a VPG. And what this does is it maintains write order fidelity across this entire VPG. So what that means is that I can recover that entire application and all its servers to the exact same consistent point in time with a few clicks of a button, as you'll see from the demo. Now, this is a real key differentiator to a lot of technologies that are out there in the marketplace at the moment. The way that the algorithms work with our journal technology and the VPGs is very unique because we can do this and recover everything to a consistent point in time. Once we have your VPG set up, we run SLA around this. So your SQL might be your highest SLA, and Zerto obviously responds and reports on the SLA for that VPG. So on my third slide, I introduced the concept of continuous data protection. So how does this actually work? The first thing you should know is we are not snapshot based. We do not use VMware's snapshots. We do not use storage array snapshots. We do not even use VMware's change block tracking. What we're doing is we sit in the hypervisor level, and I'll show you the architecture as we get further through this presentation, and we intercept the I/O coming from the VMs down to the disks. We intercept the changed I/Os, the writes which are coming down to the disks, and we send them over into a journal. Now, the journal, if you think of it as a file system, operates in the changes for the application. This journal can have a lifespan of 1 hour or all the way up to 5 days. And it means that I can recover my application from just a few seconds ago all the way up to 5 days ago. So going back to my third slide where we had the snapshots and the backups, this is giving me incredible granularity because I can pick and choose every few seconds throughout the lifespan of that journal. So this is really, really powerful stuff because it allows me to go back just a few seconds or go back a few days ago. And this isn't just protecting us from, let's say, disasters. This could be logical failures as well. Let's say a user has deleted a file on his desktop or a server patch has gone wrong. You can roll it back just before that patch was applied and bring the services back alive. So I will get into this in the actual demonstration, but as you should be aware, Zerto does both crash and application consistency within the Zerto technology. Now, crash consistency operates Zerto's own algorithms with the VPGs and the journal technology. operating systems. But again, a VSS is performance impacting, and you only want to run that every few hours because you don't want to cause any latency or delays to your end users. When we putting Zerto into proof of concept environments, I always recommend using crash consistency, which is out of the box. Because to reiterate again, we're recovering all of those servers within that VPG to the exact same point in time. The data is maintained in its write order with the technology that we're using. So if you write the data in a certain order, it will be recovered in the exact same order. Now this is huge for database administrators and application owners, because it means rather than going back to 4 hours ago to the last VSS or snap, we can just go from a few seconds ago. They have minimal data loss and minimal disruption. Hopefully you will see today as well that Zerto is incredibly simple to manage. It's a little known fact that when Zerto was being founded, the two brothers who own the company went round and discussed with a lot of leading technology companies what they thought was wrong with disaster recovery. And then they engineered a product to suit their needs. Now this is still in our philosophy today, and our philosophy is to be as simple as possible. Disaster recovery is something that we have to do. It's not something that we necessarily want to spend days and days and days of our time playing and tinkering around with. We want to have this as simple as possible and be as intuitive as possible. And hopefully you'll see this as a theme as we go through. We also give you a lot of detailed reporting within the Zerto software, such things as usage reports, CPU, memory, bandwidth, and also recovery reports, which you can serve to your end customers, departments, or teams. Okay, let's get into the technical architecture of what a Zerto installation looks like. So the first thing you should know on this is reflective of my demo environment. We are not limited to 2 data centers. Many customers or many cloud providers have many sites coming into their data centers, and you can have more than 2 sites. So the first thing that we install is a Zerto Virtual Manager. Now a Zerto Virtual Manager sits on a Windows virtual machine, 2 vCPUs, 4 gigs of RAM, and its entire purpose is to form the management layer of Zerto. So you can see we have 1 per vCenter. Now we can work with just 1 vCenter, but in this case I have 2, so I have 2 ZVMs. This is a really quick install. If the install takes more than 10 minutes for this, we're doing something incredibly wrong. The ZVM, you point it to the IP of the vCenter, we give it the credentials to log in, it does some checks, and then it's installed. We install 2 services within your Windows machine, and these are up and running, and what these are doing is communicating with vCenter's database to understand what VMs, networks, and data stores you are running within that environment. From then on in, we actually deploy the virtual replication appliances. Now, if the ZVM is the management layer, the virtual replication appliances are the replication and compression engines. These are extremely small 300 megabytes Debian Linux VMs, which are automatically deployed from the ZVM. Simply, when we're in the ZVM GUI, we see the node's IP ranges. Excuse me. We see the node's IP ranges, and we tell Zerto to go and install them. There is no manual imports of OVFs. It comes with its own HA and DRS settings as well. Again, it's designed to be as low touch as possible. Each VRA should take between 2 to 3 minutes to install maximum, and we install 1 per host. As you can see, they're extremely small on resources. 1 vCPU, 1 to 3 gigs of RAM, and each VRA can support 500 virtual disks per node. Now, I've never run into anyone using more than 500 disks per node, per ESX node. So as you can see, it's massively scalable as well. The reason that we install on each node is so the VMware admins can still use HA, DRS, fault tolerance, and storage vMotion across all the nodes, and not have to worry that the VRA may not be able to see and replicate. In 3.5 of Zerto, which is our current version, we introduced the concept of Zerto Offsite Backup. Now, going back to the GUI slide that we just had, whereby I said the two brothers who founded this based it on what people wanted, customers started to come to us and say it would be great to keep data for longer than 5 days. So the offsite backup feature allows us to replicate from site 1 over to the recovery site, and then we can take a backup from the recovery site and place it into an offsite location. Now, the word offsite there is subjective. It can be local, it can be an SMB share, it can even go into Amazon S3. The idea is to give you a longer term retention of that data. Should both of these sites go down, you have a third and final copy of your data safe in an offsite location. It's a quite basic backup requirement at the moment. It's on a schedule, daily, weekly, and monthly, with retention policies applied, and auto deletion of the retention once it has passed its retention period. And further through our product, you'll see more and more enhancements with this, which are again being driven by end users. But this is a great tool for keeping your data, having a third and final copy, and taking a backup from your recovery site reduces the load on your production service. Okay, so I mentioned that the VRAs sit in a hypervisor level, where your virtual machines are sitting. So how do we actually intercept the I/O, and what is the workflow? So the first thing that you'll notice here is my storage down below can be a VMDK, a physical, or a virtual RDM. We support all of them, which is, again, I keep going back to the SQL example, but it is good for SQL replication into RDMs. So when a virtual machine writes to disk, we see that write and split this out into the VRA. The VRA then compresses and replicates this write to the VRA on the other side, which is then passed into the journal. Now, just to reiterate again, this is any changes which are coming down from the VM, so writes. When that write has expired its lifespan, so again operating a first in, first out basis, it will be flushed down to disk and stored on the reflection copy in your secondary data center. So what happens if we lose a certain element within this environment? So let's think about this. A SQL VM could just start writing huge amounts of data to disk. The disk can't keep up the I/O, and the I/O is queuing at the disk. A VRA could reboot, or more commonly, a bandwidth or contention issue of the link going down. In all of these cases, again going back to why Zerto is enterprise in class, we go into something which is called a bitmap sync mode. Now, the sole purpose of bitmap sync is to maintain the capture of changed writes to your storage underneath. So it's important to understand here that we do not pause replication. We do not add latency to replications. We are simply ensuring that Zerto can keep up and keep the changes coming in. So what we actually do in this mode is we create an 8 MB bitmap in host memory, so in the ESX memory. And what this is doing is it's tracking the most recently changed blocks below on the storage. Now, the word bitmap here is critical. This is simply a file pointing to the blocks below which have changed. So a question we often get asked here is how much can we sustain? Roughly, we can sustain around 2 TB of change per VM in the bitmap sync mode. So it is extremely robust, and you can see why this is enterprise in class, because we are simply maintaining the capture of the changes from these applications. Once the issue has been resolved, either via manual or it has fixed itself, we copy the blocks from the pointer bitmap from the storage subsystem. We replicate between the VRAs and compress, and then we store it in the journal on the other side. Now, a point about the journals. Traditionally, with a snapshot-based technology or other replication technologies that are on the market today, you would have to provision journal space within your data stores for your maximum usage. So it might be 20% of your storage array. You may never use that, and it might be wasted space. With Zerto, we have a thin VMDK created per virtual machine. So a journal is created per virtual machine. This is a thin VMDK. They are default stored in the same data store, but can be separated out, such as SQL. You would want your SQL data, backups, and logs going to different data stores, again, which we can do. And the journal size is key here. The word thin VMDK, we grow and shrink your application according to the change rate of that application. So if your change rate is 1 GB per day, your journal is going to be 1 gig. If this then boosts to 10, it will be 10. And if it goes back down to 1, we will do a space reclaim and rebuild the journal as 1 GB. So it's designed to be as efficient as possible with your storage. Okay, so let's have a look at the automation section. I mentioned this before as we was going through and said that Zerto automates a lot of the manual tasks which would normally be associated with a failover. So the first option that we have here is an actual failover. So this scenario is my primary data center is offline for some reason, and I need to fail over and run my applications from the secondary data center. Zerto will take care of this. It will register the VMs in this secondary data center. We'll run any pre and post scripts that you wish. We'll change IP and MAC addresses. We'll connect it to the network of your choice, and then we'll boot the virtual machines on in a certain order which you wish. Now there is a step missing here. We attach the disks from the point in time out of the journal that you selected as well. So normally all of this will be run via scripts or manual processes on a single VM. Now as you can see, going back to a few slides ago, if you've got a few thousand VMs or even a few hundred, this starts to become a real big pain point. We also have the concept of a failover test, which will go through all of the same steps, but it allows me to non-disruptively do a failover test at any point in time and bring my virtual machines up in an isolated test environment. Now, as you'll see from the demo, these machines are actually live. So if I was going to do a SQL upgrade and I wanted to test the SQL upgrade patch, I could simply failover test my VMs, apply the patch, see if it works, and then apply it to production when I feel it's needed. So it's not just used for failing over or failover testing disaster recovery. Again, all of these steps are automated with Zerto. And when we are writing to these VMs on this side, we create a scratch disk, again a thin VMDK, which stores the changes that you make on this side and delete it when the test is stopped. We also have a one-click failback. So if you have been running out disaster recovery for a certain amount of time, you want to do what's called reverse protection. So you want to take the changes that have happened in disaster recovery and replicate them back to the primary data center. Now this is key because two things, we are sending the changes from here over to here, and we are also setting up replication back from secondary to the primary data center. So when this DC is back online, you have an active replication between them. One key point which I will point out throughout the demo is the feature that we have with Zerto, which is called auto commit. Auto commit is key. When we are failing over traditionally, you may have to just choose one point in time and then go to that point in time. The problem with that is if it's not the correct point in your data, then you need to either go back to your previous snap or you might be stuck. You might not have the ability to go back. Because Zerto stores the journal on the remote side, when we are failing over, it means that we can keep that journal. So we can call this an insurance policy if you like. So if I was going to fail over my DC, I want to pick a certain point. If that isn't correct, I want the flexibility to be able to roll back and pick a different point within that journal. Because just to reinforce again, I'm taking points in time every few seconds with Zerto. And this is the last slide. Few things you should know. We support all VMware versions 4.0 update 1 and above. Version 6 VMware support will be announced in time. We have had this in our labs for quite a while, so we do know that Zerto works with it. We fully integrate with vCloud Director, so we understand provider and organizational DCs and the networking within BCD. I have a fully functioning REST API of which you can automate all of the commands within Zerto via a REST API. This can also be accessed or even automated by PowerShell. Okay, so let's actually get into the demonstration here. So if I just explain my demo environment first and foremost. My demo environment is quite similar to my presentation. I have two sites, Site 1 and Site 2, and each site has its own vCenter. Now the first thing you'll know when you install Zerto is that we install within vCenter. So we install a plugin within vCenter. So your VMware admins can manage Zerto within vCenter, or you can choose to do it via the GUI, which I have here. And this is simply pointing to the IP of the ZVM, as you can see from the address up there. Now this is really key because it allows you to access this browser and simply log in and manage it. So it's quite a simple interface. The numbers in the center here, you can see I've got bidirectional replication set up, and this is the number of applications I'm replicating from each site. All of the green means that I am meeting my SLA for these VMs and applications, and as this is a lab environment, you can see that this is not a very active environment. Just within here, this is one of the active VMs that I've got up and running today, which we'll be failing over and having a look at what it does. A very, very simple Linux CRM system. And the other reason I want to show you this is just to show you that I am not using dummy VMs in here. This is actually a live up and running system. Okay, so I mentioned on the architecture slide that we deploy virtual replication appliances and that these nodes are found automatically within Zerto. To simply install these, we come over to go to Actions and hit Install. I'm just going to edit this one. And we simply give it a static IP and a host root password, and then we install within that layer. And this installs the VRAs within this environment. Now it's key at this point to understand that we actively encourage you to install Zerto within production environments. We do not require host restarts. We don't require to put your hosts in maintenance mode or into modes that are not supported by VMware. And it is the same with our upgrade process as well. It is designed to be non-disruptive. As you can see here, latest version. When this is not the latest version, Zerto will alert you, and we simply do a rolling upgrade per VRA on the nodes. Okay. Just want to show you the topology here, and my mouse catches. This is quite a useful graph when, imagine if you're a cloud provider and you have many sites replicating into you. You can give these sites names, and these are replicating into your sites. So let's actually get into the crux of some operations with Zerto. So the Zerto CRM that we see here is actually this turnkey sugar CRM system I have above there. And the first thing you'll notice is the actual RPO column here is 4 seconds. Now Zerto will be as aggressive as possible for the RPO RTO for you. We can do bandwidth throttling should you need, and we can supply priorities, as you can see in this column here, medium, low, and high. But I just want to quickly show you some of the quite good features within Zerto creating a VPG. So when we create a VPG, it's incredibly easy to do this. As Zerto is looking into your environment, we can simply come through and add in the virtual machines which make up that application. This is incredibly easy to come through and do. Sorry, there's some bleeping going on. Okay. So we add the virtual machines in here, we can see that they are added below. All of these settings on the right-hand side are where I'm replicating to. And as we can see here, we can see my journal. And we can see that this goes from 1 hour all the way up to 120 hours or 5 days. You can see the RPO alert here, which is currently set at 5 minutes. As you've seen for the actual RPO, Zerto is going as aggressive as possible to give me that RPO point of seconds. All I'm saying to Zerto in this case is, if this application, this Zerto CRM goes above 5 minutes, send me some alarms. The alarms will come in the form of vCenter alarms. Zerto integrates very, very tightly with vCenter, and you will see a lot of shared alarms. Okay, so that's pretty good. So within here as well, as I was mentioning, we can specify what happened to this application. Again, going back to my SQL example, you may have database servers which you want to boot up first because they are heavier than the web servers, and you want to bring them up in a staggered order. We also have a configuration per VM. So we can actually see the disks which your VM is presented. And as you can see here, I've got 2 disks, and one of them is my temp database space. Now, I've marked this down as a swap disk pure and simply because in a temporary database space in SQLs and Oracles and any other databases you may be running, replicating temporary database transactions is both wasteful as bandwidth and performance. Marking this down as a swap disk within Zerto will mean that we can replicate this data once, and then from then on in, we ignore it. Because when I reboot this Zerto CRM on the other side, or fail it over, that construct and tempDB will be rebuilt. So you can save a huge amount of bandwidth with this feature. We also have the option of a pre-seed. So if you have copies of your data at each data center anyway, or you plan on getting copies there via a restore or shipping the actual drives, rather than doing a full initial sync, which is again designed to be done in production with Zerto, you can point Zerto to each data store on each data center, and we will simply replicate the changes rather than the whole volumes. And just here as well, we can also see what we can do in terms of creating new MAC addresses or changing the IPs. I haven't got up-to-date tools on my VM there. If I did, it would say actual changing IPs as well. So what we're going to do is we're actually just going to run through some operations. So going back to the disaster recovery automation slide which I had, I introduced 2 main options: a failover test and a live failover. So I can pick up all of my VPGs in here if I wish, or I can just pick up one like I am doing at the moment. And when we come into here, Zerto is asking me, what point in time would you like to use? And as you can see here, as we've seen on the slide where every 5 seconds, every 10 seconds in here, 5 seconds, I'm getting a point in time within my journal. Now, you can add manual points in here as well, and this is the checkpoint button in the lower left where my mouse is. And as you can see in there, the timestamps, it can be quite confusing, and imagine if you're keeping these for 5 days, you're going to have a huge amount of timestamps. You can add manual checkpoints in there just to give you identifiers. So if I was going to do a SQL upgrade, I might just put last known good points or SQL upgrade fine. Okay, I'm just going to hit OK there. This is being replicated from Site 2 over to 1. And when I hit Next, we'll just flip to my Site 1 vCenter, and we will start to see some actions happening. Okay, so the first thing that we can see is that the VM is now registered with vCenter. And you can see it as Zerto CRM testing and recovery, which I've just highlighted. We have registered the VM with vCenter. We are attaching the point in time which I selected out of the journal. We are creating that scratch disk on the other side. We are doing any re-IP, change marks, pre and post scripts, and then finally booting this virtual machine in the order which you selected on your VPG. The only difference in my test environment is I have this connected to an isolated port group. This is pure and simply because it is designed to be a sandbox environment rather than connecting this to my production vSwitches, which may cause issues in my production environment. So we can see that this machine is now being powered on. It is now up and running, and if I simply flip back to my browser where I was before, we should see no change within the actual application. So the Zerto CRM is still being replicated. It has an RPO of 4 seconds. And just to highlight this, if I come into the actual CRM application which this is hosting, we can actively flip around in here. This is still active. There is no problems. So this is not offline. As far as my end users are concerned, testing is not disruptive to them. They are still carrying on as they would normally do. Okay, so within this testing environment, I can then choose what I want to do, whether I was just testing a failover, testing my disaster recovery strategy, or I want to actually go and apply some patches. As you've seen before, that environment is live. You can go and do all the testing you wish on there. The only caveat with this is we're creating this scratch disk to store the change rights. So we are limited by the size of your data store. Now, you can provision loads more space to your data store and keep doing failover testing, but let's say that you have a test and dev department and they want a completely isolated copy and they want to work on this for, say, several weeks. I would recommend just using an offsite clone with Zerto. And basically what this does again is it takes a complete clone of all of the servers making up your VPG using the checkpoint technology, so from just a few seconds ago or up to 5 days ago, and you can point this to a data store of your choice. And the benefits of this are you don't have to manage snaps. You're not doing snaps of snaps and clones of clones within VMware. You can do this all at the Zerto level, which is really, again, quite powerful. Okay, so we can see over in the top right here that Zerto has one task waiting for approval. And the task waiting for approval is Zerto wants to know when I would like to stop my failover test. Now I can stop this failover test at any time that I wish. And we can add notes into the column here, and we simply hit stop selected. The workflow for this now is the VM is powered down, the scratch disk is deleted to save space. The IPs are all changed back. The disks are deattached. The VM is deregistered from vCenter, and we actually create a report for you in a moment to show what actual RTO that you got within your environment. So failing over testing, no problems. A few clicks. Live failover. So let's just pick another one. When we go to live failover, the only difference which we're going to see in this case is a little different to the screen. I'm just going to force shut down my VM because in a live failover environment you would assume that your source side VMs are offline. I'm just going to put a commit period of 80 minutes on there. So after 80 minutes, Zerto will come back to me and say, hey, are you happy with that point in time? If not, I can then choose to go back further or forwards through the journal. Again, we get the checkpoint technology. I'll just take the last point from just a few seconds ago. And we can hit next and fail over. Again, this is going from site 2 over to site 1. And we will see Zerto go through all the same steps we've seen in a failover test. The only difference which we're actually going to see is that Zerto will power this machine on to a production network of my choice. So that if I validated this point in time, you can see it's just appeared there, Zerto support desk. I could then decide to start routing user traffic to this and running out of DR. So again, this should just be going on my VM network, hopefully. Here it is. And you can see it's going through all its steps, again, automating all of these manual processes you would normally have to do and bringing this live in a DR environment. You can see it's now powered up and running. We have an IP. We're up and going. Within Zerto, we have all back to a different point in time within my journal and have the flexibility of bringing up the best point in time for the business. At this moment, I'm just going to hit commit to simply show you this reverse protection. This is the one-click failback which we talked about before. And this allows me to capture any changes which have happened in DR, replicate them back to production, and also set up replication from DR to production. So again, you are then hitting your compliance of replicating between the two sites. The process Zerto goes through at this moment in time is you will see it commit the failover, and then you'll also see it go through something which we call promoting. And this is taking that point in time I selected and putting it to the front of the queue in the journal. So it's the first in and the first out. Then we will do what is known as a delta synchronization. And this is a delta sync looking at the source side and the disaster recovery side volumes to ensure that the data is both consistent and exactly the same. Again, as you can see, this is very, very easy to do. There is no going to separate GUIs or complex CLI operations. This is all extremely easy. Just while that's doing that, I just want to bring you to the recovery reports, which I mentioned on my slides as well. And we should see the Zerto CRM, which I have here, which we failed over tested before. And I can actually generate a PDF for this. Okay. And if I just save, and we can just open this, just give me one moment. Okay, when my PDF viewer starts to open, there we go. So this is automatically generated by Zerto. We can see the operation which I did, a failover test, the start and end times, and more importantly, the recovery time objective. The recovery time objective is classed by Zerto as the time it's taken Zerto to do all of those manual tasks you would normally do. Your RTO might be a few hours because you need to do some database testing, consistency testing. But this is showing you that your operations is extremely easy to do and it's extremely fast. We can also then get an insight into all the steps that I kept discussing when we were doing these operations of what Zerto was doing underneath. So you can see we went through all these steps in under 30 seconds, enabled you to fail over all of those VMs in that VPG. Now again, you can do per application testing or you can do site-wide testing with Zerto. It doesn't really matter. Just one last thing to show you within here is the offsite backup that we have configured over there. Now with the offsite backup, as I mentioned before, Zerto out of the box does replication from one site to the next site. What we are then doing is we're taking a backup from the remote site and we are actually doing a full backup from the remote site. Now again, this reduces load on production and it extends the retention period for my data. So I could back up to a repository of my choice. Now you can have multiple repositories per on each VPG, it doesn't matter. this one here is going to actually my local drive within my Windows 2012 box with deduplication turned on. It can go to any SMB share, so if you have dedicated data domains, exagrids, quantums, they can go to there. We set a schedule as you would expect of a backup product and a retention period, and this allows you, if you lost both sites, to restore within Zerto, just using the restore button here. And this takes us to our backup catalog, whereby we can choose a restore point. As you can see, I'm only taking them every week here just to save on space, but you can see we're taking a full backup, and I can restore if both sites have gone terribly wrong. Just to point out a few more advanced features within Zerto up on the right hand side here. As I said within my demo when we was looking at the workflow of this, we can do time-based bandwidth throttling as well. So if contention is an issue or you have busy periods between your data centers, this is not a problem. We do provide support for virtual vCloud Director, that is not a problem. And just to go back to the point I made before as well, these are all the versions of VMware which we support. You are not limited by having to have the same version of VMware at each side of your DR. We are not bothered, we can go through between each versions, providing that your virtual machine version is similar and you're running the same version of tools. Okay, we will see in the background now that this is going towards the Delta Sync. And once this has passed this Delta Sync during my live failover, the replication will be continued and it will start to meet its actual RPO and SLA again. So simple failover test, failover and failback, extremely easy to do, all can be powered by the VMware admin, no need for storage engineers, network engineers, application engineers. A VMware admin or someone who has access to the vCenter can do this all as one. And as you can see, it's a very easy installation to run and operate. At that moment in time, my demo and presentation is done. We've got 7 minutes to spare, so I'd like to open it up for any questions if people do have any.
Come on now, don't be shy.
Sorry?
I was just encouraging people to talk, Darren.
Just for the people that are on mute.
Okay, okay. Well, if there are no further questions from now, thank you very much, Darren, for that. We'll call this to a halt for now. We are contactable via email or phone or whatever else, and obviously via your Concord account managers. Please do let us know if there are any questions arising, and thank you for your time.
Any questions, Mike? Okay, thank you very much.